How's everybody doing? Wow, you guys are very enthusiastic. Fantastic. My name is Terry Ryan, and I'm a developer advocate for Google Cloud Platform. And my mission today is to kind of walk people through what is a typical journey to taking an app that you've had somewhere else and bringing it to Google Cloud. And my focus is on virtual machine technology. So a pattern we see from a lot of people is when they first come to GCP, they want to do what they've done elsewhere, but on us. So how do you do that? How do you get started? That's my goal today. So if that's what you signed up for, great. If not, well, hopefully you'll stay. So before I get started, it's really important for me to know who everybody in the audience is, and I'll probably do this with just a show of hands. So who here is a developer all the time? Okay. Web developers? Mobile developers? Back-end developers? Okay. How many people here do systems work? I see some overlap with the developers. Is it because you love DevOps, or is it because your company won't hire more people? Which is it? Okay. Anybody else? Any other, are there designers or UX people, UI people? All right, fantastic. Anybody who tells any of these other people what to do? Any managers in the room? Okay. So there's a lot more of us than there are of you. So one, manager jokes fly. And two, I hear your systems people could use some more people. Just I hear that from the crowd. All right. So I know what jokes I can make. I know who you guys are. What are our goals? Our goals are to take someone from a journey. I've got an app, and I want to get it on Google Cloud Platform. That's my primary goal. My secondary goal is to sort of point out a whole lot of things about GCP along the way, but that's a secondary goal, so I'm going to fall way short on that. There's a lot of GCP that I'm not going to talk about. Hopefully, I'll point you in directions where you can, if you like it, you can start learning more and go that way, but just be aware that this is not super comprehensive. Okay, so you have an app, you have it running someplace. We usually do what we call lift and shift, where we pick something up and just plop it on our cloud instead of running it on your own data centers. So I want to show an app here, so I'm going to switch over to my laptop. And this is a super, super simple app called Tagger that I wrote, just to kind of, it's minimum viable product, right? It's just to show what I'm trying to do off here. So you see you have a bunch of tags and a bunch of kids because, you know, always get points from the audience from showing cute kids. I'm going to go ahead and just show you that this is a real thing. It's running locally on my laptop, but it could also be running, you know, in a data center somewhere in my own on-prem center. So I'll hit Gladiator, I'll hit open. Nothing up my sleeve, I've got a real app here running. I'll upload, and there we are, app is working. Now, I'm going to switch back and talk a little bit about the architecture in slides. So, very, very basic, simple app. Again, written to illustrate this stuff. I've got one single box, which may or may not be the way you want to run your stuff. If you are, it's OK. And if you're not, please don't judge me too harshly. So I have a single server here, and it's running the application code, it's running the file system, and it's running the images, right? All of that is on one space. And I want to move this to make it cloudy. So our eventual destination with this will look like this, where my database is in the cloud and my files are in the cloud, but my app still sits on a VM, which also is in the cloud, but you know, it's still a virtual machine. I'm not trying to get you to move to Kubernetes or serverless or anything like that. Well, I'll talk about those topics, but we're not going to move to them in this app. So, okay, so we talk about virtual machines on Google Cloud Platform. We call it Compute Engine. We have several engines. Compute Engine is our virtual machines. That has some properties and some things I'm going to talk about. You can dial in how many processors you need from 1 to 96. And then you have a range of memory based on that from 0.6 to 624 gigs. You have disks. You can install 64 terabytes of persistent disk, 3 terabytes of SSD, and you can go up to 208 gigs of RAM disk with the memory on your system. Now, we have images that go with these machines already that have operating systems already set up. But you can configure your own, and actually, I'm just going to show that off in the interface. So I'm going to switch to do another demo. And you should, It was working 2 seconds ago. No, all right. It's working. All right. So I want to go ahead and create an instance. I'm going to create a new instance that I want to run my stuff on. So I'm going to hit what's labeled here, create instance, kind of a little on the nose. So I'm going to go ahead and create instance. When I do that, I can give it a name, and I can put it in a data center. So why don't we do US West, because that's where we are. But note, we can go all over Asia and Europe and South America and Australia, but I'll stick to being close to here. Now, when I go to set up my machine, there's a whole bunch of set types of machine, like 16 core and 32 core. But one of the cool things about our platform is that you can actually dial in. If you have a use case where you really only need, let's say, 44 processors to really do the work you need to do, with other kind of choices, you'd have to go either 32 and be under-spec'd, or go 64 and waste all that money on processors you don't need. With us, you can dial in exactly to what you want, and you can see exactly on the right what the impact of those choices are, right? And I got a little warning at there you go. Oh, it came up. I didn't hit it right. But it basically a little warning and said, hey, you could probably get a better price if you could figure it this way, which is kind of cool. But I'm going to go and stick with our set images, because I don't want to pay that much. And then I'll go to the boot disks. With boot disk, I have a whole bunch of choices of different operating systems, Container OS and Red Hat and Windows even. Yes, you can do Windows on Google Cloud Platform. But I'm just going to go ahead and keep with the defaults. I'm going to hit Select. And you notice I have another couple of options. I can activate HTTP. I can open up the firewall. I'm not going to do it this time around. But one of the favorite things about this interface is down to the bottom, there's this equivalent REST or command line link. So after I configure this whole thing, I click on this, and I get this little box that says, here's exactly how to do this on the command line. So I can then configure it once in the interface, and then take this and automate it and use build scripts, and I don't have to write these things from scratch, which is really helpful. But I'm going to go ahead and create this. And we like to say these spin up in tens of seconds, meaning when I'm in my hotel room practicing this, because I'm doing it at I/O, it takes like 10 seconds. When I'm in front of people, it takes longer. I don't know how it knows, but somehow it knows. So hopefully, oh, all right, good. You don't register, so I'm happy. It doesn't know you're here. Shh. All right, so I'm going to hit SSH, and when I do, instead of having to pull down certs to connect to this VM, I can do it right through this interface, right through the web, which I love for, I can travel without my laptop. As long as I can get to a browser, I can take care and manage my stuff. First time you SSH into a box, it takes a little bit of time because it is doing that manual work you used to do. It's doing it automatically for you. So at this point, and I wouldn't worry about the text here too much, but I will blow it up a little bit. At this point, what I would do is go through and apt get update, right? And then it'll fail because I should have sudoed it. So I'll do sudo bang bang to run the same command. And there, I would go through, I would do apt get update, and then I would start rolling through and installing software. I feel like that would strain our relationship as an audience and speaker if I were to just sit here and install LAMP, because that's what's running on this other box. If I sat there and installed all those things over and over again, I feel like I would lose you. So I have a solution for that, which is that I've already done that on another machine. I've then taken that machine and created what we call a disk image from it. I said you could use ours, but you can also use your own. So I'm going to create a second instance here. And on this one, I'm going to open up the firewall. I'm going to open up the HTTP port. And when I go to select images, instead of using OS images, I'm going to use custom images. It's going to take a second. And we'll see here that I have one called Tagger Latest, which I already built. And I'll hit select. And now, when this app comes up, it will be running completely the whole software stack. None of my software is on there, none of my app is on there, but all the supporting software I need is there. So hopefully in a second, this will come up. Hopefully it has not identified that you're here. And when it comes up, you'll notice that I have these external IP addresses here, and some of them are linked and some of them aren't. The one I just created wasn't linked because it didn't open up HTTP, but on this one I did, so when I click on it, it should go right to the Apache Debian default page. So I've installed, I have software running on a VM, it's all set, ready to go. So one last thing I want to show you before I switch back to presenting is up here in the upper right, I've got this little command prompt. It's another one of my favorite features. instead of having to install all the SDK and all the stuff it takes to manage Google Cloud on my laptop, I can just use Cloud Shell. It spins up a little VM under the covers that I don't get charged for. It's got a home directory, so I can use it over and over again. I can save scripts there. But now I have I have access to this without having to install all this stuff on my computer. So really helpful, really, really great for trying stuff out. So with that, I'm going to switch back to presenting and talk through a little bit of what I did here. So if you want to start doing this, programmatically and repeatably and kind of put it into your build cycles, you can do all of what I did here with gcloud command. So this one is gcloud compute instances create. That's how I create an instance. And then I would probably want to run commands on those boxes, so I can do that. Gcloud compute SSH virtual machine name and the command I want to run locally or remotely. And then finally, I have files that I want to get onto those VMs. I can do that with gcloud compute SCP. So between these three, I can completely automate the creation and configuration of a machine repeatably. And I do a lot of this. I do a lot of scripting of this stuff because I don't want to do it by hand because I make mistakes. So we talked about virtual machines and disk images. So yep, you can start with ours like I did. You put all the software on it, make a disk, and then save it as an image. But you can also make them from scratch. You can use VirtualBox to make images from scratch and upload them to us. Networking, I talked about a little bit about that you get external IPs. But one of the things I didn't talk about is that you can always get an IP address and it'll always be ephemeral. Meaning, if the machine goes down, when it comes back up, it'll get another IP address. But any of those IP addresses, you can grab and say make static and keep. And so like if you start fooling around with a box and you set it to ephemeral, and you're now worried because stuff is now depending on the IP address of this box, you can grab it, hold on to it. We don't charge you for those. The only time we charge you, and this is something that members of my team just learned, is we only charge you for it if you don't use it. So if you have an IP address and it's in use statically, we don't charge you for it. It's when you park on it that we have like a little nominal charge, just a couple cents. It's just enough to kind of disincentivize you from holding on to IP addresses for a long time. Or holding on to a lot of IP addresses for a long time. Showed off the firewall that you can create rules. I just did the HTTP rule, which we've kind of automated, but you can create arbitrary rules, and they get applied the same way. They get this tag that gets applied to your machine, and that's what'll determine whether or not your firewall is open on the machine. One thing I didn't show off is something called Cloud Launcher. Our VMs, our images start at the software layer, like the OS layer, but if you want, like, I don't know, like Cassandra or WordPress or Drupal or something like that on your machine, you can use one of these and sort of shortcut like having to do the whole build. Now, it's important to know that we don't manage it once you build it. We just help you build it. All right, I'm going to take a slight detour and I talked about Cloud Shell for a second. That's really important. Like I said, it's a little VM. And you have a home directory that follows you, which is like you shove scripts in there that you use all the time that'll be there the next time you go to Cloud Shell. And it basically means like I never have to, like, while I love having my laptop, I never actually have to have it somewhere when I might need to log into Google Cloud Platform. All right, we're back from that little diversion. So now let's talk about storage, right? Because that's the crux of what this app does. It stores files and it stores data. I'm going to start with the files part of it, the images. So for images, we call that blob data because, I don't know, that sounds gross, I guess. Cloud storage is the tool for that. So it's for files, for videos, for pictures, for unstructured documents. Now, there are 4 types, and I'll talk about them, but they all have the same interface. And the metaphor is you've seen with other cloud providers, the idea of a bucket and objects in that bucket. That's what that's how cloud storage works. So we have the 4 types. We've got multi-regional, regional, nearline, and cold line. And they all have different use cases and different costs associated with it. Long story short, multi-regional is for global data. It's for you pushing the data as close to the people that are going to be using it. So it's for people outside your company. It's for web presence. It's for web apps. It's for mobile apps. It's for streaming video. Regional, in contrast, is you want to keep the data close to where it's being used, just like in global, but for this, it's being used for internal purposes. It's for running data jobs and doing big data analysis on large data sets. You want that data near the computers that are going to be doing that, but don't necessarily have to be near the public. Now, another thing to note here is just because it's regional doesn't mean it's only accessible from the region it's in. It just means that it is fastest in that region. And you can still pull this data from other places around the world. So you're not restricted of where you can use this data from. Nearline and coldline are long-term storage options. Therefore, in the case of Nearline, it's for backups and long-tail media, stuff that's going to be used regularly but infrequently. And for coldline, it's things like compliance and disaster recovery. So if you're pulling down data from coldline, you're probably also loading your resume in an editor, just in case, right? So that's sort of the distinction we use for these. Now, as we go to the right, the price goes down because it's less accessible and less easy to get to. The time to first byte for global or multi-regional versus coldline. Coldline is a little bit slower, time to first byte. And so accordingly, the costs go down. But for nearline and coldline, when you retrieve the data, you get charged for it. And in this case, it's 1 gigabyte per, all those prices were gigabyte per month. This is per gigabyte. So when you pull down data out of nearline, it's going to cost you a cent per gigabyte, and at a coldline, 5 cents per gigabyte. The idea here is we want to encourage you to store stuff and hope you never need to use it. And that's why the pricing is set up that way, to sort of encourage that sort of use. Now I'm going to do a quick demo of cloud storage, so I'm going to switch back to my laptop here. I'm going to show how easy it is to sort of set one of this up. I'm going to go ahead and, like I said, it's a bucket, so I'm going to create a bucket. I'm going to call it Tagger 102, because the names have to be unique. I'm going to just go ahead and create it. It's multi-regional, so I'm now creating a multi-regional bucket. It's already ready for me. I'm going to upload the files. I'm going to take my files from here that I already had. I'm going to upload them. Let's see how our network is doing. OK. Wi-Fi network is, there we go. All right. So you'll see I have a whole bunch of images here now loaded in. Now, I can't get to any of these. I mean, Google Cloud can see these and share them among Google Cloud apps, but I can't, the public can't see them. The way I enable them to the public is I can just click this little thing here and say, I don't know, share publicly. And when I do that, I get a public link. So even though I just uploaded it, it's now globally available and able to pull down. If I were to URL hack and change it to, one of the other images was that kid in the Ewok costume, which is Ewok JPEG. I hit Ewok JPEG and it's not there, right? So you can be very granular with what you share and what you don't share. So I'm now going to switch back to presenting. Oh wait, I'm not going to switch back. It'll switch back on this. And let's talk about a little bit what I did. I wanted to upload files, and you can do that with the gsutil command on the command line. That's how I do most of this, right? Because I don't want to manually put all my files through a web interface. I can also share publicly using gsutil. I can set up the settings. You can do them per file. You can also do them per bucket. That's how I tend to do it. I share the bucket, and then I try not to have shared and non-shared stuff in the same, even though you can. Just saying, for me, I don't want to accidentally share something, so I usually try to make that distinction at the bucket level. Now, my app was writing to file storage on the server. I now needed to write to cloud storage. So for that, I want to use our client libraries. Now, our client libraries, you'll see, there's a whole list of languages they're available for. If your favorite language is not here, one, I apologize. Two, we have a REST API, and it's pretty well documented. So you can sort of do this stuff without needing the client library. But this app was PHP, so I don't have a problem. So let's walk through this. Please don't judge me for PHP. I figured it was very readable. Move uploaded file, source destination. So something's been uploaded to the server. We move it to a file location. To do the same thing but point it to cloud storage, I have to pull in the storage library and then create a storage client and a bucket and upload to that bucket. It's a little bit more code, but not tremendously more. And dropping it in was relatively simple and painless to do. So that is client library. So now here's where we are. We've carved off images. We now have our application code and our database still together, and we need to fix that. So let's talk about databases. With that, we'll go to application storage, and we get the SQL versus NoSQL. And that is not anything that I want to wade into. I'm sure we all have beliefs about SQL versus NoSQL. It's OK. I'm not going to question any of them. But I'll talk about what we have for these two places, or these two types. So we have Cloud SQL, which is a traditional SQL server. It's MySQL or Postgres. And it's what we call vertically scalable. You can keep making the machine it's running on bigger and bigger, but at a certain point, when you need to scale out, these don't scale out perfectly well. You can do replica sets, and we make that easy to do, but it is still just good old-fashioned vanilla MySQL and Postgres under the covers. We just manage the backups, and we make it easy to set up replicas, and we take a lot of the pain out of running these machines. Now, we also have this other thing called Cloud Spanner, which, like, let me put in context, you would never use on this app. It's for gigantic worldwide companies that have, very high rates of queries per second. It is not for this Tagger app. But that's also available to you. It has a SQL interface. It's structured data, highly available, strongly consistent. Our network makes that work, where we can make those claims that it is both those things. And it's horizontally scalable. But keep in mind, it is definitely cost effective when you have the scale for it. At like this small app, it would be overkill. So now I'll talk about NoSQL. NoSQL, we've got Cloud Data Store and Firestore. I'll start with first. Anybody here use Firebase? OK. So Cloud Firestore has a lot of integration with Firebase, and there's a similar product called Cloud Firestore for I forget the branding of it, but it's the same thing. And basically, it allows you to use Firebase's APIs to write to a gigantic NoSQL store in the back end. It's really great when you're writing mobile clients and web clients that you don't want a back end at all. You don't want application structure at all. You just basically want the front-end app to talk directly to the data store. That's what Cloud Firestore is for. Cloud Data Store is more for I've got an app that I've written that I also want to store stuff to, and that's running on the back end, and that communication would happen between Cloud Data Store and the store, and your app. And then finally, Bigtable. You don't see it a lot in applications, very rarely. Like someone will come out and use this for an application because it's got very low latency. But where it really excels is big data jobs. You put a whole bunch of logs in there and store them and run through stuff in that. So that's Cloud Bigtable. It's another one that's only cost effective at scale. So which one should we use? Well, I kind of set this up so that there is an obvious winner. I'm not going to rewrite all my logic from SQL to NoSQL. So I'm not going to use any of the NoSQL solutions. And Cloud Spanner is overkill, so I'm going to use Cloud SQL. We got on the next one. And I'm going to use MySQL instead of Postgres because, again, I don't want to rewrite stuff. So I'm going to do a quick demo of this to show you what this interface looks like. I've got SQL here. I already have a database set up, but I'm going to create a new one. And you'll see I got some options, MySQL versus Postgres. And we actually kind of help you, like, what are you going to use this for? Are you going to use it for development, for staging, for production? I'm going to use staging because among its many features, it has this, which is automatic increases storage. So when I set up my disks on the back end, it will automatically make my disk bigger if I start to run afoul of the size of the disk, up to 64 terabytes. So I'm going to go ahead and configure one of these. I can choose version, I can choose machine type, so I can make the machine bigger. They're based on our VM images. You can't customize them, but they kind of fit with the VM standard images. You can choose SSD or standard disk. But one of the cool things you need to know is that if you need higher read-write performance to your disks, you need to give bigger drives. And you'll see when I change this number over here from 20 to 200, all of a sudden I get more IOPS and disk throughput. So keep that in mind. You might need to make bigger disks to get better performance. OK, so I think that's what I want to show off about Cloud SQL. So I'm going to switch back to present mode. I'm going to switch back to present mode. There we go. Oh, I'm pressing the wrong button. All right, I'm all over the place. All right, so how do I get my stuff into Cloud SQL? It's relatively simple. I take it, I upload it to Cloud Storage, and then from Cloud Storage, I ingest it into Cloud SQL, which brings up something kind of important, which is this workflow, move it to Cloud Storage, and then pull it somewhere else is actually pretty common. You have a whole bunch of log data, you put it in Cloud Storage, ingest it into BigQuery. You have images that you want to analyze with our machine learning APIs, put it into Cloud Storage and have them analyze it. And you'll see two tools here in the center. Cloud Storage is one of those that acts as a hub. The other one is something called Cloud PubSub. There's actually a really cool demo of PubSub in the Cloud Dome, in case you're interested. But what PubSub does is it's a messaging bus. You say, I'm a publisher, and there's a whole bunch of people who subscribe to the channel that you publish to. You send a message, a structured piece of data that does something, and it gets navigated, it gets communicated out to all the people that are, all the subscribers of that service. It's very high throughput, so basically it allows you to basically offload stuff to other pieces of the cloud when you need to, and do it with a queuing system that's really, really robust and fast. Okay, we'll segue back and talk about some common problems people have when they start running database servers on us. So one problem, and I filed a bug, but I feel like I should communicate it to you, is that when you run gcloud SQL to ingest the SQL, you might get an error, and that error is going to look like this, internal error. And then when you raise the verbosity of the gcloud command, you get that it's a SQL error, which is helpful, but not really, because we kind of knew it's SQL. So what you do is in the SQL interface, there's this tab called Operations. And in Operations, we can see that there was an error. We can actually see the line number. We see all the SQL data that we need to troubleshoot this. For this particular error, it was that I had done a MySQL dump like you normally do, but I had some super permissions, which you can't have on Cloud SQL, and so it balked at that. So just a couple of things that if you're switching over to this, you might want to know off the top of your head before you head desk trying to track down what this is. Now, what happens if we, Google Cloud, don't offer something that you need? Like we have MySQL and Postgres and our NoSQL solutions, but you want Cassandra or Mongo or one of the other storage solutions. Well, you do two options. One, you can build it yourself from hand, build it yourself from scratch. Yeah, mixing metaphors. Or you can use Cloud Launcher to build one of our existing solutions like Cassandra, Redis, Mongo, CouchDB, and a whole bunch more. In each of these cases, it's important to note that we don't maintain the software for you. We maintain the OS. And so like in all the cases with Compute Engine, I didn't mention this earlier, but we do something called live migration. So when you update the machine, it will continue running even through the update. You'll never have downtime because we're updating the hardware. We migrate and solve that for you, so you don't have to deal with that. So in each of these cases, you get that with whatever solution you build, but we won't update the software or run backups for you for them if we don't say we do like we do with Cloud SQL. All right, so now here we are. We have taken our app, we've moved it to the cloud, we've put it on a VM, and then we've offloaded database and storage to different parts of the cloud. So now I'm free to start thinking like, well, since all of the data, all of the state of this application is elsewhere, then I can start making interesting decisions about how I run this. Do I want to run a group of VMs behind a load balancer to make sure that I've always got redundancy? I can do that. If I want to go to a serverless solution, I can do that. If I want to go to Kubernetes, I can do that. And I'll talk a little bit about how to do this with a VM. So how do I scale this system? So I'm going to switch to demo one last thing, I believe. And that's going to be something we call managed instance groups. So another error, just refresh. And there we go. So these take minutes to get rolling instead of seconds. So I'm not going to strain our relationship and do things that take that long in front of you. But I will kind of walk you through creating a managed instance group. So basically, I define a group, and I say, I want this to be a group of Tagger machines. I want them all to have Tagger on it. I want them all to run with the same software. And so what I do is I can say, well, I can put this in a single location or multi, so I can have these groups all around the world. I put it in a particular zone, and then I can be managed or unmanaged. Managed means that every machine is based on a template, and they look exactly the same. So we can do things like, say, auto-scale. So all the machines are exactly the same. If the CPU utilization ever gets above 60, spin up another one, and then spin up another one until it gets down below 60. And it can scale down. And so I can say things like, make sure there are always 3, no more than 10, and scale with 60% processor utilization, which is what I have for the one that I have there. And so I can build that, and you'll see that I did here in this interface. So I have these 3 machines, and if I click through, I can see that each one of these machines is running. Each one of these machines is open to the internet, and each one of these machines is running Apache just like I want it to. So we're all good. So where'd I go? So the next thing I want to do is take this and make it redundant, basically share it with the world. To share it with the world, I need a load balancer. So I'm going to pull in Tagger load balancer, which I've already set up. And again, this takes a little while to go, so I'm just going to walk you through the way it's set up. And it's pretty simple. I say, give me a front end. It's HTTP. It's on port 80, and serve it up on an IP address. And then I say, from the back end, serve this instance group. So this instance group, everything is open on port 80. You're listening on port 80. Combine them and make that redundant. So once I do that, I have this set up the way it is. Each one of those machines is answering calls to the internet. But if I go to this machine, this IP address that I get here, it's also up and running. And so like I said, these will scale. All of that scaling can happen usually within a minute to 2 minutes. So if you start getting a load spike, we can scale up load relatively quickly, but not necessarily instantaneously. Okay? So that is scaling out this application with a load balancer. So with that, I'm going to switch back to presenting and take you through a couple more things. So we talked about instance groups, right, which are, they can be managed or unmanaged. Why would they be unmanaged? Well, maybe you want to combine a 2 CPU box and a 60 CPU box. I don't know why, but you want to. That's cool, like no judgment. You're responsible for scaling and all of that because we can't figure out CPU utilization, like what should we add? We don't have any of that set up. We're not using a template. So you can manage that. But if you use manage, we can auto scale, and we can also auto heal. If you have health checks on your app and it goes down, we can rebuild a VM for you and bring it back into the instance group. Networking, talked about load balancers. We have HTTP and HTTPS load balancer, which is equivalent of an L7 if you're used to that. We also do TCP and UDP load balancing, and we have internal only that are only accessible within your project. Now, that's how I scale VMs. But I do work for Google Cloud, and we use the buzzwords container and serverless a lot. So I felt like it was necessary to at least talk about these. How many people here are already using like Docker? Okay. How many people are using Kubernetes? Okay. All right. For those of you that aren't, I'll give just a quick what is containers at a very, very high level, and watch the faces of the people that raise their hands as they squirm and squeam through this really, really oversimplified definition. Containers are basically a package that contains all the code and runtime components to run a particular process, your app. And then there's an environment, Docker or Kubernetes, that will trick the process into thinking it's the only one running on the machine. And so you can do crazy things like have multiple versions of the same software running on the same machine. You can stack as many more processes on a machine than you can do VMs on the same hardware. So basically, there are a lot of efficiencies you get from switching to this model. We have two products that we say are container products on Google Cloud. They're Kubernetes Engine, which is managed Kubernetes, which if you don't know what Kubernetes is basically you have dozens or hundreds or thousands of containers all doing different things. You want to run them in a way that you're not managing individual containers. You put them into a Kubernetes cluster with instructions on how to run them, and it'll keep them running whether they're a microservice, a web app, or a batch job somewhere. App Engine Flexible is if you just want something, you have one app that you just want to scale, and it's already in a Docker container, you can push it to App Engine Flexible, and we will scale it for you from one to as many instances of it you need. What is serverless? So serverless is a marketing term. It is, right? Like there is a server there. It's not. There's not some beast living beyond space and time running your server, your load for you. But it describes, like I think, a really important distinction, a different type of app, which is you pay as you go. Whatever you use, you pay for. If you don't use it, you don't pay for it. And you don't care about the underlying infrastructure. You don't have to know about number of servers or number of nodes or anything. We will just run it for you as much or as little as you need. So when we talk about serverless on Google Cloud Platform, we're talking about two things. We're talking about cloud functions, which the unit of abstraction is a function, right? And you attach that function to some sort of event. Someone drops a file somewhere into a bucket. Someone sends a message to a pub/sub queue. You respond to it with that simple cloud function. We also have a serverless solution that's app-based. Now, it's very restricted in terms of what you can do. You can only use certain languages. You can't use third-party code. You can only use code in that language. But what you get for that restriction is incredible scaling. App Engine can scale from 0 to pretty much infinite in a relatively short period of time. I have a demo where I will scale an app that's cold, like I didn't use it, to about 8,500 QPS, queries per second, in about 5 minutes. And to put that in perspective, 8,500 QPS is what Wikipedia gets. So I'm able to go from nothing, cold, to like a Wikipedia scale application in 5 minutes with App Engine. But again, it comes at a cost, restricted abilities to do things. So the question is, should I switch over to one of these? That's like a whole talk. That's like a whole separate talk of whether or not it should go serverless, virtual machine, or containers. But I'll say for this app, without any context, no, right? Like, it's working where it is. I'm bringing it over someplace else. I don't necessarily want to put a lot of effort into it. Lift and shift is absolutely fine. If I have plans to grow this app bigger, or to grow it with a whole bunch of other applications, maybe it might make sense to containerize. But again, that would depend on the context. And if I'm going to have very inconsistent use, then maybe serverless would work out too. But for this particular app with no context, I'm not switching it over. I'm staying on VMs. OK, we've come to the end. I've taken you through a pretty good tour of what we have here. We started here. We started with a single app, all running on one machine. But we ended up here, where we've basically taken all the state, pushed it elsewhere, and we can now grow and expand and have a lot of different options with the computing level. Now, there was so much I couldn't cover. I was pretty vicious with my editing pen because I wasn't getting under 40 minutes. So I didn't talk about our ML APIs, which are awesome. So what you could do with our ML APIs, same sort of insert in the code the way we did cloud storage. You can grab, with Vision API, you can take this. I'm not going to switch, don't switch over. But you'll notice there that I have tags that I got from Cloud Vision API instead of making people do it. So this app, I could just completely replace data entry on this app with Cloud Vision if I wanted to. I think it's funny, a little detail is that it thinks that the Ewok, the kid in the Ewok costume, is carnivoran, which is kind of scary, but I don't know how he's raised. I don't know. So just, if you see a kid in an Ewok costume, be afraid. But Cloud Vision was able to do that for me. It also picked out skin and children and picked out a whole bunch of details from those images. I didn't talk about the API library. So if you're using any of the other Google APIs like Maps or YouTube or Ads, you can manage them through here and use them in your Google Cloud Platform project with default credentials that you don't have to set up a lot of certs and a lot of credentialing information. You can just run it with kind of very minimal authentication, but securely. Didn't talk about Stackdriver. If you need your logs or monitoring and all that stuff, Stackdriver can do this for you. All this stuff I didn't give a chance to talk about will all help you run in this scenario. So if we look at Google Cloud as a whole, I talked about the compute platform. I think we covered a lot of it. We covered storage and databases. We covered a little bit of networking. We covered the tiniest little bit of big data in that I mentioned PubSub. Mentioned the machine learning APIs, mentioned developer tools, and mentioned management tools. But if you look at this whole list, there's a lot of missing because there's just a lot more to the platform. So I'd ask, if you have any questions or if this has ignited anything in you, please make sure you stop by the Cloud booth. There's everybody from Google, not everybody, but a lot of people from Google Cloud are there and can answer your questions. And hopefully, I showed you how you can onboard and how you can get started with Google Cloud. Keep in mind that if you sign up, you get a $300 free credit for 12 months that you can use to kick the tires. And hopefully, you go from here to discovering more about what's on the platform. So thank you very much. I've been Terry Ryan. Please feel free to heckle me on Twitter, @TPRyan. If you have any questions, I'll be around. But I think I'm running short on time. So have a good rest of your I/O.